Welcome to exponential functions. Today we're going to talk about how you graph exponential functions not using an XY table. So we're again going to start by looking at parent points. This is what the graph of an exponential function looks like. Our general form is f of x equals a to the x. So here we have graphed y equals 2 to the x. Important things you need to get down. Your parent point you have is 0, 1 always on any graph. And then your second one is always 1 and then up the base number. So we're always looking at the number that has the exponent as our base. We also have what we call the asymptote. We talked about before that graph would never cross your x-axis. Well, now we're going to talk about what the asymptote is and where it goes. So the asymptote is always going to start at y equals 0, and we'll talk about how that could move. So if you remember what we did before, our rules of transformations, if we have a negative in front of it, that means we're going to flip it down. When we had the plus or minus on the outside of parentheses before, this is just plus or minus after our exponential. That's going to cause it to go up and down. Remember, if it's plus, it's up. If it's minus, it's down. And then instead of having a parentheses, we have our understood set of parentheses up as the exponent. So remember in that one it was the opposite sign. So plus meant left and minus meant right. So remember we always went in the opposite direction when you were looking at something inside parentheses. So here we're going to take a look and graph a few of these exponentials. First thing we have to look at is our parent points. So we said the parent point of any graph always starts at 0, 1, and 1 are base. In this case, 4 is the number that has the exponent, so it's going to start at 1, 4. Now what we want to look at is this minus 1. It is up in the exponent, which is understood to be in the parentheses. Since it's minus, if you remember we said that meant to go right 1. So when I graph these, I'm going to imagine where 0, 1 is, and then I'm going to go right 1. So if I go over 0, up 1, and then I need to go right 1. That's going to be where my first dot is. Then we have the coordinate over 1, up 4, but then I want to go right 1 again. Before I connect this, I have to look and see where my asymptote is. It always starts at y equals 0. So if I take this horizontal line of y equals 0 and I go right 1, it's still going to be in the same spot. So when we graph an asymptote, we always do it as a dotted line. And so my first graph is going to hug the x-axis and then go straight up. So that is the f of x equals 4 to the x minus 1. Our next one, we look at the number out here. That is not in parentheses. So we know that tells me to take each of these points and go up 2. So I'm going to take each of these points over 0, up 1, and then I want to go up 1, 2 more. And then my other parent point of over 1, up 4, so 1, 2, 3, 4, and then up 2 more. And then again, my asymptote of y equals 0, the horizontal line, if I move it up 2, it actually does move. So I have my dotted line here at 2, and then the graph looks like that. The last one, we have the negative in the front, and what that does is that tells you to flip it. So we're going to reflect it over the x-axis. So if I take the coordinate 0, 1 and reflect it over the x, it goes down here. If I take the coordinate 1, 4, so over 1, up 1, 2, 3, 4, and reflect it down, that puts my coordinate at 0, 4. And since my original asymptote is the x-axis, it does not move anywhere. So then there's my graph for f of x equals negative 4 to the x. So those are different things that each of the numbers in the equation do to the graph. So now what we're going to do is we're going to take several different graphs and try to graph them and then find domain and range. So here is example 2. Now unfortunately these graphs are not near as easy as the last ones when we did our function dance, where you could just do your starting point and your slope. This one, there's going to be a bit more work to it. So we always start with our parent points. Our parent points, we always start with 0, 1, 1, and your base. So we have to look, the number that has the exponent on it here is 1/2. And then we also have y equals 0 as an asymptote. Now from there, we look and see what is happening to it. We see that we have a 2 that's being multiplied and a 3 that's being added. The easiest thing for these, in my opinion, is just to do these operations to the coordinates. When I multiply by 2, remember multiplying comes first in your order of operations, so I multiply 2 to the x term. So I'm only multiplying 2 to the x. And since that's y equals 0, I do not multiply that by 2. So my new coordinate turns into 0, 1, and 2, 1/2, and I still have y equals 0 as my asymptote. Then we look at the plus 3. Please remember that's your up and down, which means that's your y value. So I'm going to add 3 to each and every one of my y's. Since my asymptote is a y, because y equals 0, I add 3 on there. So what this does is this gives me the coordinates of where my graph should be after I have all these movements. So this turns into the coordinate 0, 4, 2, 3.5, and then y equals 3 is now my asymptote. So all I have to do once I've done all these operations that were in this equation, I just have to graph it. So then we have a nice, neat graph. So we have over 0 up 4. We have over 2 up 3.5. And then my asymptote at y equals 3. And so this is going to be a nice wide exponential graph. The last thing is domain and range. So if we remember domain and range, your domain is left and right. I see that very easily my arrows point to the left and to the right, so my domain is all real numbers. My range is up and down. What you need to notice is it is always going up, but it stops at my asymptote. So my range is going to be y, since it goes up, is going to be greater than, and it's going to be my actual asymptote here, which is 3. Notice it does not have an equal to here like we did before, because it will not ever actually reach a positive 3. So there's my domain and range for this graph. Next example, same kind of thing, different numbers. So we need to take a look here. My parent points, as always, start at 0, 1, 1 in the base. So we look, the exponent now is on the 3, and then we have y equals 0 for the asymptote. The numbers we need to deal with, the negative 0.25, the plus 1, and the minus 4. Remember, deal with whatever's multiplying first, and it always, always, always multiplies to the x term. So we're going to go ahead and multiply each of these by the 0.25, all these x values. So the first one stays as 0, 1. The next one turns into negative 0.25, 3. And then y equals 0. So up in the exponent, remember that